Hi, and welcome to our Vision Series presentation. Before we begin, we have to cover our safe harbor statement. We're going to be looking at some forward-looking technologies, and we don't want anyone basing purchasing decisions or investments on the presentation. So please review the safe harbor statement before we begin. Okay, welcome to our Vision Series presentation. In this presentation, we're going to be covering open standards, some important work that Autodesk has been doing in the open standards area, and we'll start by looking at how open standards are really essential to modern production and how they're charting a path to a more resilient future. So for today's presentation, we're going to cover these topics. I'll start out talking a little bit about these production challenges that we're all facing. We'll move on to looking at some incredible work that's being done with LookDevX, with MaterialX. We'll take a look at what's being done in Bifrost USD, and then we'll close out with a talk on Hydra viewports. So when we discuss open standards, it has to be in this larger context of modern production and the challenges that we're facing. And these challenges really come back to the unique times we're living in. We're in a content boom that is unlike anything that humanity has ever really lived through. If you think about it for a moment, never before in all of human time have so many stories been told to so many audiences around the globe in so many different new ways. And the reality is that things are just getting started. When we think about the content boom, it's important to recognize that it's not a monolith. This is not just a singular content boom. It really has different areas that are unique with a lot of overlapping aspects. Film and TV is perhaps probably certainly the best known for me. And film and TV is really about how audience appetites have been changing, right? The expectations of what audiences uh, have and what they expect to see on screen have really, they've become incredibly sophisticated. And the old separation between what counts as feature film quality versus TV quality, well, streaming has thrown that completely out the window, and audience expectations are that they're going to see high quality visuals regardless of whether they're sitting in a theater or whether they're watching at home or on a mobile device. And that demand for visual quality, visual complexity is only going to continue. More and more is being put on screen than ever before. And I think we all know that experience of watching a visual effects film and or an animated feature and seeing just the wall of names, the hundreds, sometimes thousands of talented artists who are producing all this incredible work. It used to be that a big visual effects show would maybe have 5, 10 visual effects houses involved. Now it's not uncommon to see 20. And this is driven by the demand for sophistication and rich visuals. But streaming has also complicated things now because a 3-hour feature film used to be considered a long film, whereas now if you look at some of the series, a Lord of the Rings or Game of Thrones, and when I say Lord of the Rings, I mean the series that's I think it's due this summer. Um, these are really 12-hour, 15-hour or more feature projects. So the old adage about the differences between feature film quality versus TV quality are gone. And we're seeing similar things in games as well. So with games, it's really about just the rise of visual richness, the complexity of the worlds, just the sheer size of the worlds, and then also characters. Characters are becoming more complex, more rich, and so gaming is undergoing its own, I think, sort of a transformation in terms of the audience expectations, as well as also just the sheer variety of gaming experiences. And then, of course, we can't forget everyone's favorite buzzword, metaverse, right? And I think of metaverse as something it's not a new thing. Metaverse experiences have been with us for some time. If you look at Fortnite, Minecraft, or Roblox, for example, these are all metaverse experiences. So I think it was William Gibson, his old adage about the future is here, is just not evenly distributed. Well, the metaverse experiences are here, and and when we think of metaverse, we also have to include all of the XR experiences, VR, AR, etc. Um, and in the world of metaverse, of course, that's not just entertainment. That's also things like e-commerce. Um, and other markets. So all of these areas are booming independent of each other, but there's also a lot of cross-pollination, convergence between these different fields. And so all of this combines to this huge content boom that we're living in, and we have to deliver just massive, massive amounts of content for all of these audiences around the globe. So how is it all getting done? Well, production continues to change. Remote teams and remote work have been completely normalized. This started, of course, before COVID, but the pandemic certainly accelerated it. And every studio has implemented new ways of working in some form or another, whether that's from an IT standpoint, maybe adopting DevOps processes so that they can spin up remote sites and remote teams really, really quickly. Multi-studio projects have grown significantly. Um, for big feature film projects on the visual effects side, of course, you may have, a parent studio that's working and coordinating potentially with a number of other smaller studios. In animation, you may have a, studio that's running 4 or 5 feature projects at once, some of them done in-house, some of them being done by third-party production studios. So the supply chains, for lack of a better word, I'm not crazy about the term supply chain in this context, but the content supply chain has been changing and it's extending. And studios, and this is where that idea of how open standards and open source support resiliency in production, is that for production studios, the bottom line is that they have to be flexible, they have to be agile, they have to be able to collaborate with other studios and support remote teams. And open standards are at the heart of this. And ultimately, for artists in production, the bottom line is getting to final. And the way that you get to final is through iteration. More iterations generally leads to better quality on screen. Um, and in order to get to those more iterations, you have to have less friction in your pipeline and your process. Um, more iterations mean better work, and a key to supporting artists toward being more productive is reducing that friction. Efficiency is paramount. Anywhere that you can reduce friction, that's a win. And here in this visual, at the very top, you see in red that kind of worst case scenario, right, where you're going all the way back up the pipeline for a revision or an iteration, um, and cost will go up there, right? So avoiding those situations where you have to, go all the way up to the head of the pipeline is ideal, and then also being able to, rapidly review as you're iterating is key. But none of this is really possible in terms of the iteration process and reducing friction in modern pipelines without open standards. They're absolutely essential, and we see this as only being more so going forward. Of course, thankfully, none of us are working in a vacuum here. A key reason why we're seeing open standards succeed now is that we have organizations and their communities that are working together to progress these key technologies. Organizations like the ASWF, the Kronos Group, Metaverse Standards Forum, um, they deserve huge shout outs. They're essential, and I really urge everyone to get involved however you can. Modern production is incredibly complex, whether you're in film and TV, games, metaverse, and these technologies, these open standards, can't be developed in isolation. It takes, it takes a community, it takes a village, and thankfully we have strong organizations now that are helping to move all of this forward. In our presentation today, we're going to focus on two of these open standards. USD, which is arguably, or maybe not arguably, the most critical open modern 3D data standard of our time. We're also going to cover Material X and developments in LookDev workflows as well, which are fantastic. To be clear though, all of these open standards here are important, and Autodesk is absolutely committed to advancing open standards across production. In addition to this presentation, I want you to stay tuned for some exciting open source announcements we're going to have at SIGGRAPH this year. So without more yapping from me, I'm going to hand it over to our presenters today to show you all the good stuff.
Thank you, Ben. In next presentation, we will give you an overview of the latest USD workflows through simulated USD pipeline. All of presented is created using the out-of-the-box tools. We are not claiming this will be absolute guide workflow for your pipeline. However, we did line up this presentation in the spirit of how USD is supposed to be understood for a given problem. We are starting at the modeling stage where USD export is used to convert Maya geometry to USD. In this particular case, we will not use powerful material conversion options since material authoring will be happening in LookDev stage using the LookDev X toolset. Let's go over some basic steps regarding LookDev workflows in USD. First, we need to load export geometry for modeling. We will load geometry through USD layers so we can always get updates from modeling team. Again, all of this can be easily automated. Now we need to create a layer where our materials and material assignments will be recorded. In order to capture our action, we need to make our layer as a target layer. When enabling target in the layer, all USD changes will be recorded at that particular layer. This is an important step to remember since so far we have now some user-friendly troubleshooting process in the case you unconsciously write data to unwanted layer. Now, let's examine current state of direct material assignment in Maya USD. We can select any prim at any level and assign material. However, we need to be aware about USD rules. In this particular case, USD material strengths. Currently, we don't have UI support for USD strengths. However, as you can see, material assigned on higher level in a hierarchy is weaker than their descendants. As you already noticed, we can assign differentiating data models through USD. USD Preview Surface is made for optimized preview of your materials in viewport. Material X is developed as a portable standard for materials, and Arnold materials are a complete solution for all of your complex shading requests. For now, we can notice that current Arnold materials are not visible in viewport. However, Arnold can render USD and material data models. In this pipeline example, we will use Material X and USD shade to represent materials in viewport, and Material X and Arnold shading graphs for final render. Now let's do the LookDev of one of the assets and check exactly where we're currently standing regarding authoring material in USD. In this example, we will use Material X graph for current asset. As you probably noticed already, as soon as we create USD material, MTL scope is created. This means that all newly created materials in current scene will be saved in the MTL scope at USD stage. Let's open LookDev X and graph out selected material from Outliner. As you can initially notice, we have slightly different material states than we usually can see in Maya and some other products. Material in USD is presented as a compound node graph that holds multiple shaders. In short future, we'll be able to promote attributes at the top level of USD material. I'm sure when we get at that stage, then the whole workflow will be much more obvious and satisfactory to different user types. Okay, next thing is something we do all the time, and that is graph creation. We should use only Material X nodes in this graph if material portability is our goal. LookDev X USD graph representation is an early stage regarding usability. However, code changes are coming on a daily basis, and I'm sure we will get to the desired state sooner than expected. Next is after we build material, we can start making material variations by creating new layers per desired variant. Those USD material variants will be later used in assembly phase done by Bifrost. I feel it's important to clarify that LookDev X is engineered to support natively differentiating data models. Currently, as you can see, we are natively supporting USD graph creation. Our goal is to be agnostic and support natively different data models, including MaterialX. Additionally, it's good to mention that we are engineering LookDevX in direction where we can potentially see its implementation in other Autodesk products. And now I'll handle this to Jonah, where you can check where Bifrost USD can help us in our example.
Thanks, Nicola. So as Nicola alluded to, we are preparing or packaging up our LookDev assets for scene assembly and lighting. I'd like to show you some of that and how some of that can be automated using Bifrost. This is an example pipeline, of course, and the Open Standard USD contains several concepts that we're going to make use of in this pipeline. And these include purposes, variants, and references. On the right, we can see 3 variants of the sphere asset. And this means that our sphere asset here has 3 variants, 3 different looks, that are packaged up together as one asset, which will flow through the pipeline as a single asset. Our pipeline has certain expectations. It expects our assets to follow certain rules. And in the standard for assets that we're showing, our pipeline expects a certain USD hierarchy. Firstly, everything is parented under world. So that's this group right here. And following that, we have the name of the asset, Sphere Naginata. Under that, we have 2 more groups, which represent the purposes of the asset. That's another USD concept. The proxy is the viewport proxy with a proxy purpose. And this is created by modelers as a lightweight viewport representation with viewport-friendly materials. That's the image on the left. And the geo is the render purpose with high-resolution geometry that is suitable for rendering. You can see that there's more detail, and the rope and so forth are included in the rendering purpose. Additionally, there is a standard for variants, which we saw in the previous slide. Our pipeline expects our assets to have a variant set named material variations. And all of this is pretty specific. We don't want people to have to set this up manually, so we can create a Bifrost compound to help us get all of this right. So this is our Bifrost compound, and it's built to encode the standards of our pipeline, and it speaks the language of USD. The Bifrost integration of USD will help us here because we can interface with the USD concepts themselves. And a compound is a Bifrost node that's made of other nodes. And these compounds are easy to share within your team. This compound here in particular takes in USD assets as inputs, and then it outputs a new USD asset. And at the top level of our compounds, we have a number of controls. But first, it might be useful to talk about controls that this compound does not have. This compound does not have any controls for the most basic level of organization, such as the world level of the hierarchy. And that's because we don't want to offer our users any exceptions to this rule. Our pipeline always requires this. This is a benefit of compounds. We can choose what to expose, and sometimes, more importantly, what not to expose. The first port on the compound is the asset USD path. And this is the name that you put here is the asset that is used for the USD hierarchy that we're going to generate. The USD files for proxy and render purpose, those are going to be coming from the previous step of the pipeline, and those will be organized and referenced. They'll be referenced and organized into the structure that we expect. And last, a path to output a USD file too. This compound will create a USD file on disk. So here is a quick tour of the graph that is assembling our asset with variants. It's not plugged in at the moment, so let's go ahead and do that. And as soon as I plug it in, this Maya USD proxy shape appears over here, and it's creating this hierarchy here for us. And this hierarchy is the output of this graph. So if I go and look at this graph here, I have the incorrect name in the graph here, and that is represented here. So this is supposed to be called Sphere Naginata. So I'm plugging that in, and it has recreated our asset here named Sphere Naginata. Everything else in here, including proxy and geo and so forth, is also being organized by this graph. For example, this world group here is being created right here and being set as the default prim. So that's basically just saying that when we add everything to the stage, everything goes under the world group. And after that, we have this transform here. That is, in fact, this sphere Naginata, and the path that we're adding it to is this asset USD path, which is set to the name of the asset. And these two groups right here are taking these arrays of file names. So we have 3 different file names for both proxy, geo, and variants. And they're iterating over those and creating an array of variants here. So if we look at that in Maya here again, I can go and look at a different material variation here, say material A, and we'll see that it has turned purple. And if I switch to Arnold to go and do a viewport render, we can see that this is also the purple variant, so all of our variants line up of our proxy and render geometry. And yeah, another variation here as well, material B, and I believe that has a greenish teal color. Yes, it does. And going back to the viewport, here we have our asset with the proxy representation of variant B. In the previous example, we demonstrated some simple asset processing for organization and conventions. Here, we're going to add some procedurally generated content to it, and we want to re-inject this content into our pipeline. What we are going to do here is we have these stone floor assets, and we want to add pebbles to them. And we expect more pebbles to collect in all of the cracks and crevices between these tiles. And after that, we want all this data to go right back into our pipeline. So we have a Bifrost graph that does the following. First, it finds all the cracks. Visualize this in red and teal. And the way that this works is we convert the mesh to a volume and then smooth it. And then we check how far inside or outside the volume the geometry is. And in this visualization, teal means inside or recessed, and red means outside, so little peaks on top of the geometry. And the teal areas represent cracks where we'd expect more pebbles to accumulate, and the red areas are places where we would expect them not to accumulate. And then in the black and white there, we've created a scattering mask using those cracks. We do this by processing the data from the previous step in a pretty simple way. After that, we generate a bunch of pebble geometries. So these are just little simple geometries representing pebbles, which we are going to scatter and instance all over the mesh. So that last image there are the pebbles that we're generating. And it looks almost like a visualization of the cracks because so many of them end up down inside of the cracks. Also, another thing that we're doing is we are making it so that there are larger pebbles inside the cracks. So we are controlling the size of the cracks using this data as well. That lets us have kind of denser accumulations and then little tiny pebbles on top of the mesh. Lastly, we convert all this to USD, specifically the USD point instancer. Everything in the ecosystem of USD that we have here will support the point instancer very well, including rendering and the viewport. And then after that, we can fold all of this back into the render purpose of our geometry and send it down the pipe. So we can take in an asset that is this tile without pebbles and then output it so that in the rendering purpose, we have our thousands of pebbles scattered all over our asset here. And this is procedural, and we have several assets that we can apply this to. We can use this for pipeline automation and apply this to all these assets. So in our set that we have, we don't have just one tile for the ground. We have this little bit of stairs here. We have another tile for a different style of ground that's on a different level. And we could also expect that as the project progresses, that we might need to create more of these. We might need to extend the set in other directions. We might want to create variations of the tiles, and we might want to add, in entirely different pieces as well. And so all of this can be automated. We can run this from the command line as well and run these graphs on additional tiles of geometry. So, a quick tour of the scene and the Bifrost graphs that produce the pebbles. We start with the displaced mesh here, and this mesh was created by modelers, and it has all these irregular cracks and chips and so forth, and we need to find the recessed areas and fill them with pebbles. So the first thing that we do is we convert it to a volume, and this is a heavily smoothed volume. So we can see if we unhide this original mesh that parts of it are poking up above this smoothed volume, and those are the high areas. The parts that are inside will be the recessed areas. So hiding those two again, here is the Bifrost graph that is flagging the areas that are inside of the volume, and then adjusting them with an F-curve. That's this graph right here, and it's got this curve here, which controls basically for a depth how much does it scatter. If I go and change this graph, then you can see that the values there change. And after that, we have the scatter graph that looks like this. This is more or less a standard graph, a standard scattering graph. It's pretty straightforward as far as scattering graphs go. And it is essentially just scattering points, creating instances, scale points, using some data that it takes off of the mesh there to put smaller points over here and then bigger points over in the cracks. And it's also creating the pebble geometries procedurally. So it's actually creating 20 random pebbles. If I change the random seed here, then we get 20 different random pebbles. So hiding that graph. And then the last one is the graph that creates USD and the USD proxy shape. So this is the USD proxy shape. If I go and look at my instancer in here, and we see that we have the floor geometry right here. That is the mesh that we were using and the instancer, which we can keep exploring, and we can see all 20 of the pebble variations that we created here. If I go and change this graph to create, say, 100 pebble variations, I need to go and reframe that in my outliner here, but we can now see that there are 100 pebbles. And we can go and see exactly where each of them ended up. And with that, I will hand it back to Nicola for scene assembly, lighting, and rendering. Thank you.
Okay, let's move to our first step in our sequence. It's a layout sequence. So as we can see, Layout Artist is creating USD references of assembled assets. As we mentioned before, all assets are assembled in Bifrost. Again, through Asset Management System, asset loads can be easily automated. Geometry we're seeing in Viewport is proxy geometry enabled by USD Purpose, and they're all using USD Preview Surface or Material X graphs for preview in Material Viewport. There's a lot of interesting problems surfaced out during our experiment. One of them is being discussed in forums, and it's affecting many different workflows. I'm talking about USD relationship. I feel that in layout will speed up workflow tremendously and minimize mistakes if we could establish transform relationship between render geometry and proxy geometry. I guess next in line will be light linking. In our assembly stage, we grouped different geometry as USD variants for the logical groups, which is quite handy in layout and other stages in our example pipeline. Every variant has its own render representation and proxy representation. Artists only need to switch variant for selected reference. Good to mention that Maya USD is supporting USD cameras, which are used in our USD layout scene and obviously propagated through our USD pipe through other departments. Additionally, USD purposes in our pipeline are allowing layout artists to render full geometry and make some composition decision according to the testing lighting in the scene. Great, we will finish and save layout sequence file. To simplify our presentation, we assumed that our first shot in layout is actually a reuse key shot from layout sequence we just finalized. So that will help us to simply jump directly to animation. As we did in previous steps, all shareable changes will be written to our shot layer. Again, this could be automated easily, however, automation was not part of this example. Key difference in shot animation step is that we will reference Maya scene into USD stage. In this case, I'm referencing character rig Maya file. Our rig Maya file will be used later to produce character animation USD caches. I hope you can notice in Outliner where Maya data is in USD hierarchies colored using Maya Classic gray color, which additionally helping us to distinguish two different state around stages. Another Maya toolset support added for USD workflows is Isolate Select and Viewport. More is coming. Okay, my next step is to do some animation. However, I didn't have time to do some animation, and to be honest, I wouldn't say I'm a good animator. However, one frame animation caching will tell us good enough story for a given example. Our last step is to get a prop in our character hands. This time we are referencing USD assemble assets. Again, it's interesting to see how Maya and USD assets working seamlessly together in Viewport. Next step is to cache Maya anim data to USD. In this example, I simplified our material pipeline, and at the same time I'm trying to feature powerful Maya USD export, which can convert materials to USD. We will use cache to use the USD dialog for creating proxy and render caches with their materials. After animation caching is done, our character cache is referenced to USD stage and all Maya data is cleaned from the stage. Please notice a reference icon in the stage. This is the point of entry to our Maya character rig. At that point, we can always go back and add additional correction to our animation. We skipped FX assembly step where materials are added to pebbles and FX elements are connected to our set. However, you can notice FX layer is loaded in our lighting stage. Using power of USD, now we can make all kind of non-destructive changes to our scene. In fact, everyone in current pipe can work at the same time and push their changes. In lighting, could be simple material geo or variant change, or directly selecting any material attribute and adjusting it using in Maya Attribute Editor, or loading a bunch of materials in LookDevX and adjusting them. However, let's try creating shadow using tree that is positioned carefully by layout department. We choose tree that is not in camera view. Again, this change will just affect our shot, and it will be recorded in lighting layer, which then could be non-destructively shared to any other shot in a sequence. Additionally, please notice how lighting artists can simplify scene quickly by turning off assets through USD layers, and that can speed up specifically his render. In this case, that's FX Pebbles. You can notice how character and prop is missing from scene, but animation layer is present in a layer editor. Animation caches was not created at the time when lighting recorded their steps for this video. However, as soon as we created caches in anim layer, which was done in anim shot, our lighting got a character and prop ready for render. Okay, I feel this was quite a lot shared information squeezed in not too much time. However, we hope it will be beneficial to many of you who are following my USD progress. Thank you, and now I'll hand this to Hendrik.
Thanks, Nicola. So we'll switch gears a bit and talk about Hydra and Hydra viewports next. My name is Henrik. I'm a software architect in the graphics platform group here at Autodesk. And we work not only with the media and entertainment products like Max and Maya, but also many of the other Autodesk applications. So the viewport is obviously a very fundamental part of almost every single application that we have and the way that most of our customers interact with our software. And that is true for Maya and Max that we see here on the right-hand side, but also all the other Autodesk applications that we have in the AEC and product design and manufacturing industries. And of course, every application and every industry has their unique needs and requirements for the viewport, but there is also a lot of commonalities between them. We of course want the viewport to be very high performant and highly responsive as you're interacting with your content or your design. It needs to scale to bigger and bigger data sets. It needs to take maximum advantage of the GPU and other hardware resources. It needs to work on multiple different platforms like operating systems and hardware configurations and so on. So there is a lot of commonalities between the applications and the viewport needs. So it makes sense for us to share as much technology as possible between them. And sharing this technology is obviously not something new. It's something we've been doing for years. But what is new this time around is that we're doing it based on open standards. And that's where Hydra comes in. So Hydra is an open source framework to decouple applications and renderers. It was open sourced by Pixar as part of the USD distribution a few years ago. And it basically consists of two main APIs. You have a scene delegate API and a render delegate API. So through the scene delegate API, the application can describe the scene graph and the scene data to Hydra without caring about how it's going to be displayed and what type of render or graphics technology you will be used to render the scene. And so the scene data could be a USD scene graph, it could be the native scene graph of the application, it could be any scene representation that the application might prefer, as long as you implement the Hydra scene delegate API. And on the other side, you have the render delegate API, and you can write a render delegate for your renderer. And you can do that without caring about where the scene data is coming from, and which application might be using the renderer. And having these multiple different scene delegates represents the multiple heads of the Hydra, and the multiple render delegates represent the multiple tails of the Hydra. So that's where the analogy comes from. And Hydra really achieves this nice decoupling between the applications and the renderers. So as long as your application supports Hydra, you can plug in basically any render delegate that also supports Hydra. And when you're writing your renderer, you only have to write one render delegate, and you can plug your renderer into all the different applications that support Hydra without having to make multiple different plugins and different integrations. So here at the bottom, we see three examples of render delegates. We have Storm, something called Aurora, and then we have Arnold. Storm is the open source rasterizer that comes with Hydra and USD that Pixar has open sourced. It has also seen major contributions from companies like Apple, adding support for Metal, and so on. Aurora here in the middle is Autodesk's real-time realistic viewport renderer. And then, of course, Arnold is our production renderer. And these are just three examples of render delegates. There are actually many renderers out there in the industry that supports Hydra today. So that's one of the nice benefits of Hydra, is this flexibility of using many different renderers and making it easy for them to plug into your application. And another big benefit here is, of course, that Hydra is open source, and now it's quickly become more or less a de facto industry standard in how to decouple applications and renderers. So going forward, we really see Hydra as the foundation for our viewports, and Storm as our primary render delegate for our viewport graphics. But in order to support all the needs for our viewports, we need to extend Hydra and Storm in various different ways. So we're working closely with Pixar and the USD open source community through ASWF in making these extensions. So some of the examples we've listed here is more flexible text and line style rendering, selection, deep selection, selection highlighting, hidden lines, billboards, decals, draw order, multiple views with view-specific render data, mixing the result of multiple render delegates. So let's say you have Storm rendering the gizmos and widgets and text in your viewport, and then you want to combine that with, let's say, Arnold for rendering the primary 3D scene, and you want to combine them in a very predictable and robust manner. Then, of course, as Nicola talked about earlier, Material X is very important to us at Autodesk. We see that as the consistent way of representing materials across all our applications. And it's important that Material X is highly efficiently supported through Hydra and Storm, so we can have these very smooth and interactive look dev type of workflows where you're editing materials with high frequency, and we need to avoid any unnecessary translations or shader recompilation and so on. So we're working on improving the Material X support in Hydra and Storm. And the last example we have here is extending something called HGI, which is Hydra graphics interface that abstracts the low-level APIs like Vulkan and Metal. We want to add support for hardware ray tracing, the hardware ray tracing APIs there, and also a new backend for supporting WebGPU. Speaking of WebGPU, web is getting increasingly more important for all our industries, including the media and entertainment space. So over the last year and a half, we have investigated using USD and Hydra in the browser. And this is something that we actually open sourced in December of last year. So we're able to use both USD and the USD and Hydra libraries in all the major browsers through WebAssembly. We also have JavaScript bindings for both USD and Hydra, so you can write your application in JavaScript and just call into USD and Hydra. We've explored several different render delegates, and we've open sourced one of them, and that one is based on Three.js, which is the most popular WebGL library out there. And this is what you see here on the right-hand side, rendering the Pixar kitchen scene and also some other USD sample models. This renderer is pretty basic, though. It's more of an example for people to play around with. Our longer term goal is to make Storm available also in the browser. And the first step towards that is to support WebGPU, the upcoming graphics API for the web, and do that through the Hydra graphics interface. So we actually already have that working, and we plan to open source that shortly. And the next step would be to support all of Storm in the browser. But the other pieces here, USD and Hydra and the Three.js render delegate, they're already available, and you can find the source code and some demos at the link here at the bottom of the page. So we're very excited about this and the opportunity to use Hydra viewports also in our browser-based applications going forward. The last topic I want to bring up is something I mentioned earlier called Aurora. It's an open source real-time path tracer. The source is actually not available yet, but we intend to make it public very shortly. But now in conjunction with SIGGRAPH, we're making the announcement that we are open sourcing this renderer. So this is a real-time in viewport realistic renderer for quick design and look dev iteration. It's not a final frame production renderer, so you would still use Arnold or something like that for final frame rendering. This is more 20 plus frames per second, noise-free all the time, like we see here in the example video. Another goal with this render is that it would work on all the platforms and all the vendors. So it supports Windows, Mac OS, Linux, and it works on NVIDIA, AMD, Intel, and Apple. And it uses hardware ray tracing where available. Of course, we have a Hydra render delegate for it, and the renderer also fully supports Material X and standard Surface. And this render has been released in one Autodesk product so far. It's Autodesk Inventor, shipped earlier this year. We don't have any news on any other applications at this point, but we hope that this the open sourcing of this renderer will benefit the greater USD ecosystem, and that we, in addition to having Storm, we also have an open source path tracer that is available for everyone that could help accelerate development of Hydra and the Hydra ecosystem. We have a blog post with more details on the open source announcement here of Aurora, and you can find that under opensource.autodesk.com. So to wrap it up, the future vision for Autodesk is to base all our viewports on Hydra and use Storm as the primary render delegate for our viewport graphics. We're making open source contributions to extend both Hydra and Storm when it comes to more flexible viewport capabilities. We're also open sourcing, or we have open sourced rather, USD and Hydra for the web, and Storm is coming shortly. And we're also announcing that we're open sourcing Aurora, our real-time path tracer. And more details on all these open source contributions from Autodesk you can find at opensource.autodesk.com. And with that, I'll hand over to Björn, who's going to talk more about Hydra in the context of a content creation pipeline and applications like Max and Maya.
Thank you, Henrik. I'm Björn Siegert and I'm a product manager for Maya. Today I want to give you a brief overview of why we invest in open standards and especially in Hydra for our content creation suite. We are building on top of open standards, not only USD, but also Material X and OSL to leverage the full potential of Hydra. And as Autodesk, we are actively contributing to Hydra's and HD Storm's development, pushing the technology even further. We want to actively grow the community and contribute to it. By relying on Hydra, we utilize HD Storm as our default render delegate to build great experiences for our content creation suite. To deliver top quality work as an artist, it is important to work with tools which work seamlessly together. This is even more true if it is necessary to jump between those different applications. Here it is important to view your work always in context. Being it a large-scale environment, for example, which needs to be integrated into a plate, adding detail to a piece of armor to tell a subtle backstory of the main character, or tweaking the animation to captivate the audience. To achieve this, Hydra presents the perfect endpoint to visualize all the different data types, being it proprietary or native USD data. And with HD Storm, we can also run on all major operating and hardware systems with no compromises. With the flexibility of bringing different data types together and being able to integrate the render engine of choice, we can enable workflows like in these proof of concepts. The first is a tech demo running a render delegate using the Unity engine inside of 3ds Max. Here we can change the shading of a cup live in 3ds Max. But we can also utilize engine-specific features, like for example the physics simulation. Note here that Hydra ingests the data live from 3ds Max while running the engine. Or we can run a render delegate based on the Unreal Engine 5 inside of Maya. As seen in the video, it renders native Maya geometry through Hydra with scene updates and live animation. Not only can you play back the animation, you can also do edits while seeing it in context through the render delegate. These are just early steps, but we are excited to collaborate with the community and give artists the tools to tell their stories. So with that, thank you very much, and we open up for a Q&A for all the speakers.
Hey everyone, thanks for joining us. I hope you enjoyed the session. We have our presenters here with us and your questions. We've got some questions already, but you can still submit questions for the Q&A now. And we don't have a ton of time. We've got a lot of good questions, so we're going to jump right in and get to them. First up, what are the benefits of integrating open standards into your production pipelines? So I'm going to throw this one over to Jonah and Bjorn.
Yeah, I think there are a lot of benefits to using open standards in your pipeline. For one thing, it makes your data kind of more resilient to change in the software in the future. Like these, the data that you produce as part of your pipeline will be usable by lots of software far into the future, because these things have kind of wide support. And kind of in the same vein, you don't need to make your own plugins in order to read that data if you've had to do that in the past. don't know if you have anything to add, Bjorn.
Yeah, actually, a very good point about plugins. It's also like your maintenance costs in your pipeline go down because it's a well thought, well established standards you can use in your pipeline, and developing on those standards is way easier, and contributing back to them and then benefit from that, from the community aspect. What I also want to say about assets is that you more and more need to exchange assets between different companies or different people working on it, and that also makes it way easier to exchange assets, like if you're based on open standards and everyone is using them in their pipeline or in their product.
Mhm. Good question. Next up, will Material X get patterns like curvature or ramp in the future? And this one I'm going to toss over to you, Nicola.
Yeah, that's actually a really, really good question. And Material X group at Academy Software Foundation did raise the questions regarding the ramp. It happened, I believe, maybe a few months ago, and mostly happened from the side effects team who actually was implementing ramp, and they find some issues like they want to probably improve regarding Material X. It's something that we're going to do very quickly in the Look.x side, and we will definitely, if we find something that is missing, we will definitely raise that in Academy Software Foundation and definitely improve Material X. Regarding curvature, again, I personally raised that like maybe last year, and it's we had some kind of circle back, and then we tried to understand exactly what is that curvature should be in the world of Material X. In the case, again, this is spatial shader and has to be rendered by different renderers, and there we have to find a way to agree with all different renderers what is that has to be. And there is a process that's happening right now in Academy Software Foundation, and it's again, it's a work. We are pretty much like have an agreement what that has to be, what kind of attributes we want to expose regarding the curvature. Right now, it's just a work. Someone has to go there and just like finalize that. And
Great
again,
question.
there will be like additional nodes. So anyway, it's not just ramp and the curvature, but I agree those two are very important.
Thanks, Nicola. Next question. Where can we learn more about open standards? And Henrik, I'm throwing this to you.
Yeah, so we mentioned this earlier in the talk. So if you want to know more about Autodesk involvement in open standards, opensource.autodesk.com is a good landing page. Highlights a lot of the projects that we are participating in. In today's sessions, we mostly cover the standards that are related to ASWF. So of course you have the ASWF.io landing page. There's also going to be open source days, Monday, Tuesday next week, free to register, hosted by ASWF, covering most of the standards that we talked about today. So that's a good way to kind of get up developments in areas. This is also part of the Kronos group and other standards body. So kronos.org, one of Birds of a Feather sessions at SIGGRAPH would be a good starting point to understand what these standards are all about. So I think that's a good first start.
Excellent. Thank you, Henrik. Another question we had is Autodesk is a founding member of ASWF. How is Autodesk working with them today to push standardization forward? Autodesk is a founding member of the ASWF, and we're involved in a number of working groups and have been involved, gosh, in certainly USD. I think we're involved with several working groups just within the USD side of things. OpenColor.io. I think we are working internally on Open Timeline.io projects. We're involved with OSL for sure. What am I missing, folks?
Material X.
Material X, of course. Sorry, and Material X. So we're active in a number of projects that are ongoing, and of course, that's just looking at ASWF. We're also involved with working with the Kronos Group and now the Metaverse Standards Forum as well. So we're pretty passionate about advancing open standards wherever we can. As we mentioned in the talk, we see open standards as a fundamental to kind of unblocking and removing friction within production, so we can get this mountain of work done. Okay, next question. Let's see. Is there a best way to structure your assets with USD? This is a goodie. Bjorn, you want to jump on that?
Yeah, that's actually really a good question because USD is so flexible and you can basically do anything. I always recommend going first to the USD kitchen set from Pixar to get a grasp of USD and how they structure their asset. But actually, the USD working group made a public guideline it's still work in progress, but they put out a guideline how to actually structure their assets and what the best approach would be. Also going way into detail, like, hey, what is the best structure? What types to use, what the component and how the composition should work in your organization, how you should utilize this. You can find this information on the USD working group GitHub, and it's still working. Some aspects are still work in progress, but it's a really good starting point to know how to structure your assets for your pipeline.
Excellent. Great question. We've got another good one. Will I be able to procedurally assign materials to meshes in my scenes? And I'm going to go to Jonah for that one.
Yeah, sure. Assuming that you're talking about a USD scene, in Bifrost, you can do any kind of procedural processing of USD that you want, including assigning materials. And we are actually currently working on the nodes that you use to do this to make them a little bit more flexible and easier to use. So yeah, you can absolutely do procedural material assignment to your assets, based on anything that you want to in a USD production.
Excellent. So we're getting a little tight on time. Last question I think we have time for. As shown in the procedural pebble process, you're using volume to calculate cracks to fill it with pebbles, which I thought was awesome. I would like to use displacement texture there. Is the image sampler on the way to Bifrost? Jonah, I think you got another one for you. You want to close this out?
Yeah, definitely can't talk about release dates or anything like that. But image sampling is high on our list for things to do. And also, I just want to plug Sean Willis did a presentation yesterday at Vision Series where he showed how he used the SDK to implement reading of EXRs. And he's very graciously given away that for free. So yeah, you can go download his EXR plugin and read textures today.
Awesome. Well, I think that we are at time for questions. I want to thank all of our presenters and everyone for joining us for the Q&A. Hopefully you got a lot out of the presentation. Thanks, everybody.